Hi, Math 206. We're working here in linear measure. Now that we know the English system and the metric system, let's talk about a few properties of distance. So the first one is, suppose we have 2 points A and B, and then we're talking about the distance between them here. I'll call that distance AB for short, okay? So the first one is that the distance between any 2 points has got to be greater than or equal to 0. Now, when could it possibly be equal to 0? Only when A and B are the same point, okay? All right, the next, so it's basically saying that it doesn't make sense for a distance to be negative. All right, the next property is that the distance from A to B is the same as the distance from B to A, right? Which should make sense. All right, and now the third property, this is called the triangle inequality, says that if you've got 3 points, A, B, and a third point, C, that the distance from A to C plus the distance from C to B has got to be greater than the distance here from A to B. Okay. Notice that this picture kind of makes a triangle. So AC plus CB has got to be greater than or equal to the distance from A to B. All right, so one thing we should think about is when is it the case that this is equal? It's only equal in the case where in our type of geometry, when you have A, B, and C all lying on a straight line. In this case, the distance from A to C plus the distance from C to B is exactly equal to that distance from A to B. So again, this is called the triangle inequality. And we saw that in the last chapter, where any two sides of a triangle have to add up to longer than the third side. Otherwise, it just won't make a triangle. All right, now let's discuss perimeter. Perimeter is defined as the distance around an object. So usually we do perimeter with polygons, and the computation you will do is to add all the side lengths together. So finding the perimeter, say, of this equilateral triangle. So each side length is 3 centimeters, and there are 3 sides. So you can really do this shortcut where we say 3 times 3 centimeters, or 9 centimeters is the perimeter here. If you have a rectangle where the opposite sides have the same length, you can do a shortcut and say that the perimeter will be, width plus length plus width plus length, or there are 2W plus 2L. If you have a square where all 4 sides are the same length, S plus S plus S plus S, then the perimeter around the square would be 4S units. And in this example, an odd-shaped object, the perimeter would be the sum of all the sides. So I've got 3 plus 1 centimeter plus 3 centimeters plus 40 millimeters plus 60 millimeters. So notice there's a difference in the units that I'm using here. So I should do some conversions. Say 40 millimeters. Let's go back to our King Hector died by, this is our base, drinking chocolate milk. To go from millimeters to centimeters, we're going to move that decimal point 1 unit to the left. So 1 unit to the left, this is 4 centimeters, and 60 millimeters, 1 decimal point 1 place to the left, this will be 6 centimeters. So now adding everything up together, 6 plus 4 is 10, 13, 14, 15, 16, 17. So the perimeter around this object is 17 centimeters. Now, we use the word perimeter when we talk about the distance around some object, typically a polygon. But if you're discussing a circle, we use the word circumference. This will be the distance around a circle. And there's a formula for this, and that formula is that the circumference is equal to 2 times pi times r, where r is the radius of the circle. And this formula comes from thinking about a circle and trying to estimate the circumference by looking at polygons with more and more sides. So for example, you'd start with, say, a square, which the perimeter of the square does not approximate the circumference of the circle very well. But say if I changed every side into 2 sides so that I have an octagon, that octagon, the perimeter of the octagon is very close to the circumference of the circle. So it's almost like a limit process where you look at the perimeter of polygons with more and more sides, and then that perimeter gets closer and closer to the circumference of the circle. So we get that the circumference would be 2 times pi times r, where pi is the ratio of any circle's circumference to its diameter. And this is the same for any circle. And we can use the approximation that it's approximately 3.14. It's actually this strange number that has infinitely many digits after the decimal place that never repeat and they don't have any pattern. So it's called an irrational number. All right, so let's use this formula to solve the following problems. Let's find the circumference of a circle whose radius is 2 meters. So the circumference will be 2 times pi times 2 meters, or that would give me 4 pi meters, or approximately, and here I can go ahead and use 3.14 as the approximation for pi. So I do 4 times 3.14, which would be 12.56 meters. All right, let's find the radius of a circle whose circumference is 15 pi meters. So I know that the circumference is 15 pi, and that should be equal to 2 times pi times r, where r is the radius. So I can use that information to solve for the unknown radius here. So let me divide both sides by 2 pi, both sides of this equation by 2 pi, which will leave me with 15 pi divided by 2 pi. Notice that that common factor of pi kind of goes away. And the computation I'm left with is 15 divided by 2, or 7.5. So this gives me 7.5, and we're using meters, is equal to the radius. So the radius is 7.5 meters. All right. Now for this next problem, I want to find the length of a 25-degree arc in a circle whose diameter is 10 centimeters. Remember, the diameter is the distance all the way across your circle. So the radius will just be half of that. So notice my radius here is 5 centimeters. All right. First, what I'm going to do is I'm going to find the circumference of the circle, and then I'll think about the arc as being some fraction of the circumference of the circle. So the circumference will be 2 times pi times r, which is 5, or 10 pi. And now what fraction of the circle will this be? What fraction of the circumference? Think about it this way. You've got your circle, and a 25-degree arc here. And we want to find the length of this arc. But I know what the distance all the way around is 10 pi centimeters. And this angle measure is 25 degrees, which is some fraction of a complete revolution. So what fraction of a complete revolution is it? We've got 25 out of the 360 degrees. That's the fraction of a revolution that you have here. So it'll be that fraction of 10 pi centimeters. So that is the computation we can do now. 25 times 10 divided by 360. over 36 pi centimeters long, which is approximately 2.18 centimeters by multiplying 25 over 36 times 3.14 as an approximation for pi. All right, so I hope that this makes sense because we've done problems like this before where you have the angle measure for a sector of a circle, and that is some fraction of a complete revolution. And we use 360 degrees as that complete revolution. All right, let's do this last problem. Let's find the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. So it's just like this problem, only thought of a little bit differently. Let's go ahead and think about that. You don't know the radius here, but you know the angle measure is 87 degrees. And you know that this length right here, this arc length, is equal to 154 centimeters. So thinking about how we did that last time, we have the angle measure divided by 360 degrees, and we multiplied that by the circumference. This fraction of the circumference, 2 pi r, is equal to the arc length. That's the way that we thought of problem C there. So let's use that same idea and fill in the information that I know. The angle measure here is 87 degrees over 360. So that fraction of the circumference, which I don't know, it's 2 times pi times r, r is my unknown, is equal to the arc length, which is 154 centimeters. And let's see if we can't solve for r here. Okay, so r, you can do this computation if that helps. And we can use the approximation. Pi is approximately 3.14 to help us solve this. So 87 over 360 times 2 times 3.14. That'll give us approximately 1.5, and I'll round the hundredths place to 2 there. So approximately 1.52 r equals 154. So now you can divide both sides by that 1.52 to get r is approximately 154 divided by 1.52, which is approximately 154 divided by 1.52. I'll round to the nearest whole centimeter here, so I'll round that to 101 approximately, 101 centimeters. So r is approximately 101 centimeters. That's the radius of our circle. So now we finished section 14.1 on these linear measures. So go ahead and make sure you do all your homework, and please attend our office hours on Mondays, Wednesdays at 10:30.